Hello students, welcome back to my channel. Let's discuss about one of the important topic of your theory as well as practical experiment, that is assay of ferrous sulphate. And the sample is nothing but the ferrous sulphate, and for that we require a standard solutions, either it can be primary or secondary, and for this we are taking KMnO₄ as a secondary standard substance because the assay of ferrous sulphate can be performed by redox type of titration, where KMnO₄ act as one of the reducing agent in presence of acidic medium. So it is a first part of our assay of ferrous sulphate, that is standardization of KMnO₄. Why standardization is required means KMnO₄ is a secondary standard substance and it requires standardization so that it will become equivalent to the primary standard. So the detailed video about the primary as well as secondary standard I'll upload very soon. The aim of the experiment involves to perform the assay of ferrous sulphate and report the percentage purity of it. Yes, we need to know the percentage purity of ferrous sulphate in the given sample, and the reaction for the standardization of KMnO₄ involves KMnO₄, which is our secondary standard substance, will going to act as a reducing agent only in presence of acidic medium. For that we are adding sulfuric acid and will going to react with the oxalic acid. Why we are using oxalic acid is because oxalic acid is one of the primary standard substance. So the standardization of secondary standard substance can be determined by using one of the primary standard substance, so that we will come to know the exact normality of our secondary standard substance, and that will give our potassium sulfate, manganese sulfate, and along with the liberation of carbon dioxide and water. The observation of the standardization involves the solution which is taken in the burette is nothing but the analysis we are doing, that is nothing but standardization of our KMnO₄. Yes, here the KMnO₄ will act as a analyte. We know that analyte should be always taken in the conical flask, but when it comes to the standardization, it will be exactly vice versa of that. Reverse will be the things will be happening, so that the whatever the analyte is there, we will be taking that into the burette, not in the conical flask. You need to get confused in that. And the solution which is taken in the conical flask is nothing but the primary standard substance, means the substance with known concentration, that is nothing but oxalic acid. And I say that KMnO₄ act as a reducing agent only in presence of acidic medium. For that I am adding sulfuric acid, and there is no need to go for any addition of indicator because KMnO₄ will act as a self indicator, and endpoint of the experiment will be colorless to pale pink color after the titration. And the formula used to calculate the exact normality of potassium permanganate is N1V1 is equals to N2V2, where N1 stands for normality of KMnO₄, V1 stands for volume of KMnO₄, N2 stands for normality of oxalic acid, and V2 stands for volume of oxalic acid. The procedure will be like this. We need to fill the burette first. We need to fill the burette with 0.1 normal KMnO₄, which is our analyte, because we need to determine the exact normality of KMnO₄. I am saying that it is 0.1 N, but we should not believe the normality concentration when it comes to the secondary standard substances. So for that we need to determine the standardization of KMnO₄ first before going to the assay of ferrous sulphate. And whatever the content I am taking in the conical flask is 10 ml of oxalic acid, 10 ml of dilute sulfuric acid, and next step is we need to heat the content of the conical flask before its boiling point. It should not cross the boiling point of it, and then titrate the content of the conical flask against the burette content, that is 0.1 normal KMnO₄, till the color changes from colorless to pale pink color. And here we are not adding any of the indicator because KMnO₄ act as a self indicator. Yes, this is a tabular column, you can say that, and that will be like this: initial reading, final reading, and difference. I'll give you a simple example of that. First we have started the reading from 0 itself, and the initial reading will be 0 ml, and at the 9 ml we got our first reading, and second reading we have started with the 9 ml, and that is the 18.2 will be our second reading, and the difference will be noted down here, and we need to take the average of that by dividing into 2, and this is the volume of KMnO₄ consumed. The formula will be like this: N1 is equals to N2V2 divided by N1, where N2 is equals to normality of oxalic acid. We know that 0.1 N will be one oxalic acid normality, and 10 is nothing but 10 ml of oxalic acid we have added in the conical flask, and below this 9.1 is nothing but the average of the volume of KMnO₄ consumed. After the calculation, we will come to know that the normality is 0.1 N. It is just an example. You may get variation in the results, and this 0.1 says that it is the exact normality of KMnO₄ after doing the standardization. Now the KMnO₄ will be now standardized, and next it is ready for the assay of ferrous sulphate. Thank you.